Now, let's talk about virtualizing power systems and this thing called Power VM. Now, when you think of virtualization, you probably think of this: a computer, the big box, being divided into little boxes, each in some way sharing the resources of the big box. Now, if you don't know what virtualization is, there you have it. Seriously, that's really pretty much it, right? Of course, the detail is where it gets more interesting, right? Now, the x86 system is generally virtualized using a product called VMware. The resulting little boxes are called VMs, or virtual machines, and as we'll soon see, run their operating systems. And as we see here, the high-level concepts of virtualization on power systems are identical. There are some terminology changes, and of course the virtualizing product is different. It's called Power VM. And you see that the VMs are now called logical partitions, or LPARs, or just partitions. Now I'll use all three of those terms: logical partitions, LPARs, partitions, and even VMs throughout most of the courses. I won't attempt to argue using VM versus logical partition. They both have their merits in terms of accuracy. Arguably, though, logical partition is a bit more descriptive, while I must admit I favor the sound of VM. So let's just say I'm going to stay neutral in that debate. Now, taking a closer look at the logical partition, you see that each can be viewed separate from the big box as an independent operating environment. Mostly independent anyway. Okay? Specifically, a logical partition is implemented as an abstraction of the system hardware resources, processor, memory, and I/O. It is meant to support multi-kernel environments on the same physical system, that is, different kernels in different partitions on the same machine. The partitions are logical because the division of resources is virtual and not along physical boundaries. However, there are limitations. These limitations are defined in a set of configuration rules. The system uses firmware, this is the critical part of Power VM, to allocate resources to partitions and to manage the access to these resources. This firmware is underlying software that is running on a system independent from any of the operating systems running in the individual partitions. And although, like I said, there are configuration rules, the granularity of the units of resources that can be allocated to partitions is flexible. For example, you can add just a small amount of memory, if that's all that is needed, without a dependency on the size of the memory cards. Also, you can add memory without having to add more processors or I/O slots that might not be needed. So in the end, you can think of the logical partition's operating system environment in the same way you see it on a bare metal system. You have a console, right? And then you have the storage and the data areas that hold the operating system, the application programs, and in some cases the application's data. And then application and system logs. The operating systems are independently tunable in each logical partition on the server. And of course, each logical partition has its own network time and date settings. You can see the logical partition is truly an independent operating environment, even though it is sharing hardware with other logical partitions. Also understand that while a logical partition is created and instantiated on a server, it can go through state changes in the course of its lifespan. In addition to the obvious power on and power off state changes, similar to booting and shutting down the operating system, but not exactly the same, the logical partition can be relocated to another server due to failures. That's called VM relocation or live partition mobility. Or for maintenance or performance reasons, it can undergo a dynamic resource allocation or deallocation change, also known as DLPAR. And on some models, it can be suspended and then later resumed. Now, taking the resource allocation story a little bit further, let's look at this in another way. You can see the resources of the big box, they're allocated and managed by the hypervisor into each of the logical partitions, which are shown here as boxes surrounded by dotted lines, all within the larger blue shaded big box. The mix of resources is controlled by configuration settings and can be changed without disrupting the partition's operations. The assignment of the I/O slots in the big box necessarily assigns the adapter that's in that I/O slot, and likewise any of its attached or peripheral devices being assigned as well. Okay, the list of possible I/O adapters varies by model, but you can assume that there's a supported adapter for all common types of I/O for all our systems. And although I'll cover this in detail later, the I/O concept is extended to include virtual I/O via the assignment of virtual I/O adapters. And shared resources, as would be expected, include things like electrical power, cooling fans, core memory, and of course the chassis.